All right, open up your book to section 9-3. We are on page 450 in your book, and the title of this section is Area of a Triangle. The objective here is given the measures of two sides and the included angle, or that would be side, angle, side, or the measures of all three sides, that would be side, side, side. We want to be able to find the area of the triangle. Now, you already know how to find an area of a triangle. We know that it's 1/2 the base times the height. But realize for that, you have to know the height of your triangle. That's not one of the side lengths unless it's a right triangle. So we're talking about knowing either two sides and an included angle, or all three sides. Can you tell me what the area of the triangle is? So we're in essence coming up with two additional formulas that we already know for finding area of a triangle. All right, so let's take a look at the first one here. Given side, angle, side. For the area of a triangle, two sides and the included angle. In triangle ABC with sides A, B, and C, it turns out that you can find the area of that triangle by taking 1/2 B times C times the sine of A. Notice that A would be the angle between sides B and C there. So this is why it's side, angle, side. So area is equal to 1/2 B times C times the sine of A. And it really doesn't matter what two sides and the included angle you're working with here. You could write this actually three different ways. You could use sides B and C like you see here with angle A, or we could write it in terms of sides A and C or A and B. And obviously the included angle with each of those. But here's our formula then. 1/2 B times C times the sine of A. All right, let's take a look at where this comes from. And we're going to draw a triangle here and mark the vertices and the sides of this triangle. So let's call this vertex A, and we'll call this vertex, we'll put vertex C over here, and this will be vertex B. And we're going to call this side here on the bottom, where this is going to be, of course, B. It's opposite side, opposite angle B. This will be side A, and this will be side C. So with this, I can draw in a right triangle here. Actually, I'm just going to draw in really what the height of this triangle is really what I need here. That this is my height. We'll call him H. But if you want to, you could sketch out this little right triangle is really kind of how we're going to set up this problem here. And this angle is angle A. All right, so let's do a similar calculation that we did for law of cosines in the previous section to help us prove that. If I want to find out what the height is equal to, I could use angle A and I could use side C to help me do that. That would be the sine of this angle. The sine of A would be equal to H over C. And if I want to find out what H is equal to, just move C to the other side. I'm going to write it H is equal to C sine of A. There's what the height of our triangle is. So to find the area of this triangle, the area turns out to be equal to, we know how to find area. Again, I mentioned that you already know one formula. That's the formula we're going to start with. We know it's 1/2 the base times the height. All right, so the base of our triangle that we've got sketched up here is the bottom. We're going to call the base the bottom of this, which would be B. So it's 1/2 B times the height. We called it H, but we figured out what H was equal to over there. H was equal to C sine of A. And I guess if we just get rid of the parentheses, we got our property, right? I've got 1/2 B times C times the sine of A. Again, there's three different ways I could actually write this. One way with using angle A, another using angle B, and another using angle C, and obviously the corresponding sides that go with each of those angles there. But there's our formula for the area. 1/2 B times C times the sine of A. Given two sides and the included angle, we can find area. All right, so let's take a look at example 1 here. Example 1 is a problem where they're going to give us a triangle, A, B, and C. And it says A is equal to 13 inches, B is equal to 15 inches, and angle C is equal to 71 degrees. So notice they've given us two sides and an angle, and the included angle in particular is what they've given us in this problem. So let's draw ourselves a triangle here. Call this A, B, and C. And again, they told us that angle C was equal to the 71 degrees, so we know this is 71 degrees. And they told us the two sides there. They told us that A was 13 inches and B was 15 inches. And again, they've given us units in this problem, so we'll make sure that when we calculate the area, we include units in our answer. All right, so all we got to do is run this through that nice little formula that they gave us here. So our area is equal to, and I would make sure you write out the word area, especially when we have an angle here called A. Don't call this just A. Call it area. Area is equal to 1/2. It's going to be 13 times 15 times the sine of the included angle there, which is 71 degrees. All right, so let's grab our calculator and punch that in and see what we end up with here. All right, so again, make sure you're in degree mode when you go to do your calculation, but we've got, I'll put this in as 0.5, or oops, 0.5. You can write it as 1/2 if you want to, times 13 times 15 times the sine of 71 degrees. And we end up with 92.18806. Let me just grab a picture of that. All right, so we can write that our area is equal to this 92.188. And again, this is area. The units they gave us for our side lengths were in inches, so this would be in square inches for area. We're multiplying the 13 inches by the 15 inches is how we're ending up with square inches here when we get done. So 92 square inches there. All right, let's take a look at another example here. Look at example 2. Example 2 says they want us to find the area of triangle JDH. And for triangle JDH, they tell us that J is equal to 5 centimeters, D is 7 centimeters, and H is 11 centimeters. Okay, so for this one, they gave us 3 sides. They gave us side, side, side for this one. But again, I'm going to start out with a sketch. We've been doing that for each of these problems here. I think that's a nice way to start these. I'll call this J, D, and H. And again, label the side lengths that they gave us here. They told us that J was the 5 centimeters. So this is 5 centimeters. They told us that D was the 7 centimeters. And finally, H, they said, was 11 centimeters. There we go. All right, now they want us to find the area of this. So the formula that I have is based on knowing two sides and the included angle. And since I don't have an angle here, I'm going to have to find that angle first. So I got to go back to what we learned in the previous section here and use law of cosines to help me come up with that. I guess it really doesn't matter which angle you find, but I'm going to go ahead and find the angle that's opposite the largest side here. I guess at the same time I'll find out whether this is an acute, obtuse, or a right triangle here. So let's set it up that way. But it wouldn't really matter which angle you find. You could pick which one you want to do. So let's take 11 squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of angle H, they called this. All right, and we're going to solve for H the same way that we solved this in the previous section there when we were trying to find an angle. Subtract the 5 squared and the 7 squared. 11 squared minus 5 squared minus 7 squared is equal to a negative 2 times 5 times 7 times cosine of H. Divide by that coefficient over there, so I've got 11 squared minus 5 squared minus the 7 squared divided by this negative 2 times 5 times 7 is equal to the cosine of H. And we're going to have to use our calculator to come up with that value here, so let's go ahead and grab our calculator and find out what H is equal to. Actually, let's just write this as a fraction here in a second. Let's let our calculator help us crunch those numbers here, though. All right, so we have 11 squared minus the 5 squared minus the 7 squared. So that's 47. And the denominator there was a negative 2 times 5 times 7. I guess we should be able to get that. That's 70 there, negative 70. But anyways, let's go ahead and write that as 47 over a negative 70 is what we've got. And then we'll find out what h is equal to. So we've got the cosine of h is equal to negative 47 over the 70 there. So to find out what h is equal to, h is equal to the cosine inverse of this negative 47 over 70. Again, remember that we don't have to worry about the plus or the minus, and I don't have to worry about the plus 360n, because I'm talking about an angle that's in a triangle. So I already know I'm going to pick the positive, and I'm already going to pick that n equals 0 for that. All right, let's crunch that number there on our calculator. Grab your calculator and let's see what we have. So now if we take the cosine inverse, again, make sure you're in the right mode here. I'm in degree mode of 47. Actually, I'll put the negative here. Negative 47 divided by 70. And we get 132.177. I'll take a picture of that. Put that over here in our work. All right, so we end up with h is equal to 132.177, 132.177. And it looks like we've already done quite a bit of work, but we haven't even done the work that they asked us for, right? They asked us to find the area of this. So I still have more work to do in order to find the area. All right, so let's use that now to find out what the area is equal to. So our formula for area is equal to 1/2 the two included sides. So if you need to go back to your sketch here to remind you of what we've got here, the two sides here, the two sides that give us our included angle. So our included angle is h, so the sides that we're looking at are the 5 and the 7 here. So it's 5 times 7, 1/2 5 times 7 times the sine of this number we just came up with here. I'm going to just write the sine of h here rather than writing out the 132.177, but you could write it that way too. And let's evaluate that. We need to grab our calculator again and have it crunch that value for us. So we've got 1/2 of 5 times 7 times the sine of that value there, right? I'll just use answer there. And you end up with 12.9687 there. Let me grab a picture of that. I guess that's the picture I really needed here. I'm just going to get rid of the previous one. All right. So there's our area. Area is equal to the 12.969, I guess we have 12.969. And again, if they give you units in this problem, then make sure you include that in your answer. So if you go back to your original sketch here, they told us that our side lengths were measured in centimeters. So that means our answer is going to be in square centimeters, centimeters squared. 12.969 square centimeters. All right. The other formula that we want to talk about is for how do we deal with a triangle when we know all three sides? Well, actually, that would have been helpful for the previous example probably, because that's what we were given, right? But nonetheless, we have a formula here that's called Hero's formula, and it's because it's named after a guy named Hero. So Hero's formula is a way that we can calculate the area of a triangle if I know the length of all three sides. So in triangle ABC with sides A, B, and C, it turns out that the area is equal to the square root of this. It's the square root of S, and we'll define S here in just a second. S times the quantity S minus A times the quantity S minus B times the quantity S minus C. So you take S, you subtract A from it, B from it, and C from it, find the product of that, and multiply by S again, and you got yourself an area. Okay. S, by the way, is called the semi-perimeter. We call it the semi-perimeter because the full perimeter would just be A plus B plus C. The semi-perimeter is half that, so it's half of A plus B plus C. So you have the semi-perimeter is 1/2 of A plus B plus C. So that right there is Hero's formula. He tells us how to find the area of a triangle given 3 side lengths, which, like I said, the previous example that we just did would have been nice to know. Well, in fact, that's what the next example here is going to ask us to do. Example 3 there on page 452. It says there, find the area of triangle JDH from example number 2, but this time using Hero's formula. And of course, we want to confirm that, in fact, we get the same result. We better get the same result between the two. Shouldn't matter which method I use to find area, I should get the same answer both ways. So let's check that out. So let's sketch this triangle here. I know we had it sketched previously, but we'll sketch it again. So here's J, here's D, and here's H, JDH. And J, they told us, was 5 centimeters. D, they told us, was 7 centimeters. And H, they told us, was 11 centimeters. So this time, we're not going to have to find any angles. I'm just going to take the 3 side lengths that were given. But before I do that, I do need to find out what this semi-perimeter is equal to. So we'll do that calculation here first. So we're going to say that S is equal to 1/2 of, it's the 5 plus the 7 plus the 11. So that's our semi-perimeter. So 5 and 7 is 12. 11 gives us 23. Half of 23. I guess you could write it as 23 over 2. Maybe I'll write it that way first. But 23 over 2, that's 11.5. That might be a nicer way to work with that in my problem. All right, so now let's find the area using Hero's formula. Area is equal to, it's a square root of this big, long calculation here. So it's the value of S, which is 11.5, times S minus A. A was equal to, I guess in our case it's J, right? Minus 5. And then 11.5 minus, in our case it's D, so that's the 7. And then 11.5 minus the value of H, which was 11 in this case. All right, so let's grab our calculator and see what we end up with. Hopefully we get that value that was around 12 here that we got on the previous problem. All right, so yeah, 12.969, there's the value we're looking for. Let's see if we end up with that. So I've got the square root of 11.5 times 11.5 minus 5, 11.5 minus the 7, and 11.5 minus the 11. And we get, hey, look at that. The exact same value, 12.969 is our result. So let's write that down, and don't forget we want to include units here if they're given to us in the problem. 12.969. And again, they gave us these units here for our side lengths in centimeters, so that means our area is going to be in centimeters squared. All right, that right there is the 2 area formulas to know to calculate the area of a triangle given side angle side or side side side. That is the end of section 9-3.